Hello everyone, how are you? Today we are going to discuss one of the very important topic of mechanics that will help you solving many questions, not only one particular chapter. All the chapter like rotation you want to solve, gravitation you want to solve, sometimes in electrostats also, fluid mechanics also. So we are going to discuss work energy theorem, and don't take this topic as one topic for one chapter. It is a fundamental that will help you solving questions in many chapters. Okay, so let's start. Work energy theorem. Obviously the topic, if you will see only the written heading here, work energy, so we are somehow relating work to energy, right? And whenever work is being done, most of the time some energy is changing. Some energy like conservative force will do work, some energy will change, non-conservative will do work, some energy will change. So in a lighter mood, if you want to understand what this theorem tells, that theorem tells how work is related to energy change. Which force work will change which kind of energy. That is basically work energy theorem. You can take a very basic set of train your mind to get I am going to relate work to change in energy. Now how to do this? How work is related to change in energy? So we will start this discussion with a very simple logic of, let's have a look. Suppose I am saying there is a ball. Okay, there is a ball. This ball mass is m. Now we are applying force on it. And it is, let's say, initially at rest, and you are applying a force on it. What will happen? Then it will accelerate and it will go some distance. Obviously, distance is to being traveled, but speed will also increase. Initially it was at rest and its speed is increased. Now you say the speed is v. Why it is v? How it can increase? Because if I will take according to Newton's second law, we know that F equal to ma. So when we have applied the force on the body accelerated, and due to acceleration, velocity has changed. Hence here magnitude of velocity, speed also changed. So this is Newton's second law, which tells that there is an acceleration cost, that is F by m, which is change in velocity, final minus initial divided by some time taken. Initial velocity was 0, final velocity v, so we got some speed because of this force causing acceleration here, and acceleration is changing the speed. So we have discussed one very simple query, when ball is being acted upon by a force, why it accelerated, why its speed changes. And to discuss it, to get the answer, we used Newton's second law. Now we want to do the similar thing, the same thing, but with the different logic. What is the different logic? Try to get, this is the force here. When you are applying this force, the body is displaced also. And since it is displaced here, this is the displacement, we can say there is a work also. So work is equal to F dot S. And here is a work. What this work is? Positive work or negative work? Force is where? Right side. Displacement is where? Right side. So work is positive. Positive work means, if I say positive work here, means we are adding the kinetic energy. Positive work adding kinetic energy, you can say kinetic energy is being added here. And kinetic energy here, since speed was 0, so kinetic energy was also 0. At this point, final point, kinetic energy is half mv square. So kinetic energy is added by the force. How? Force caused work, and work, that positive work, it added the kinetic energy. It means kinetic energy added, subtracted, it means kinetic energy is being changed. So entire mechanism is what? You are applying the force. Force is causing the work, and work is changing the kinetic energy. Again we got the answer of the same query, when we applied force, why speed increased? Answer is kinetic energy has been added up, that's why speed is increased. Earlier we answered this by Newton's second law, and we took help of force. Now I am doing the same thing, same query, but I am not talking about force here, I am talking about work. It means same query can be answered by Newton's second law as well as by work and energy relation. So we can just conclude something, work energy theorem is the scalar treatment. Scalar treatment, what I am saying, because work is a scalar, kinetic energy is a scalar. Scalar treatment of Newton's second law. So that is the Newton's second law only. Newton's second law, like whenever you apply force, momentum changes, body accelerates. That same thing if you want to discuss in terms of work and energy, that is called work energy theorem. So that is the basic thing. Work energy theorem is just a scalar treatment of work energy theorem is a scalar treatment of Newton's second law. Got it? In Newton's second law, you are dealing with force and acceleration, momentum change, those are vector quantities. Now you are dealing with work and energy, that is the scalar quantity. But still we didn't know okay, what is work energy theorem, exactly what is that theorem. So if we get to know okay, what is theorem exactly, theorem is this, see, work done by all the forces on a system equals to change in its kinetic energy. Okay, so whenever you are doing work, you are changing the kinetic energy, and that is called work energy theorem. But in this, when I say work, I simply say work. I am not mentioning the force, or you are doing a numerical and then there is a work. So most of the questions you will see work is always written by a force, work done by gravity, work done by spring, work done by some that force, work done by friction. But simply when we say work, that is work done by all the forces, the network. So work done by all the forces, that is the important point, all the forces on a system equals to change in its kinetic energy. So whenever you want to solve it, look in that way. How many forces are acting on the body? Take all, how many forces means all, you don't have to be choosy with the forces. Internal forces are there, external forces are there, conservative is there, non-conservative is there, pseudo is there, as many forces acting on the body, and how many forces are acting, that you have revised in Newton's second law, the free body diagram. Got it? So there also if you want to do revise that, that will help you a lot in solving work energy theorem. So we will take it that work done by all the forces means as many forces are acting, conservative forces plus work done by non-conservative forces. If the motion is being absorbed by an observer who is in non-inertial frame, the pseudo will also be there, plus work done by pseudo forces. This all will be equal to change in kinetic energy, final minus initial. Change in kinetic energy, that is final minus initial, right? This is the basics of work energy theorem. Only thing, when we do question, I will tell you how to go in the question, what to problem solving strategies of always different. There is a basics, then there is a conceptual question, then the problem solving strategy. That accurately I will tell you in couple of minutes. But here we have just done with what is work energy theorem. It is a scalar treatment of Newton's second law, and this reads that all due to all the forces, it is equal to change in kinetic energy. Now we will see how this comes. What is the basic derivation? Just basic derivation, sometimes it's required for problem solving also. The approach is very, very clear. So we will see what is the basic approach for that. Have a look. Suppose there is a block, okay, this is the block, and this block has speed v. This block is moving with speed v. If I will ask you what is the kinetic energy of it, so answer will be kinetic energy is half mv square, that is the kinetic energy, half mv square. Now if speed will change, kinetic energy will also change, or if mass will change, kinetic energy will change, or if both will change, but here I am taking a constant mass system, so we will consider the change of speed only. So m is being taken as constant, let's say. particle dynamics we are doing, mass is constant. So if I will differentiate kinetic energy, dk by dt, m, as I said, it is a constant and 2 is already a numeric constant, so m by 2, v square differentiation is 2v, and then it is dv by dt. I am differentiating that expression number 1 with respect to time. What we are getting? Have a look. dv by dt, if you see this expression, what is that? Acceleration. dv by dt is acceleration, 2 gets cancelled. Here it is ma into v, and we can write v as rate of change of displacement. So dv by dt, this is written as a, and velocity is written as ds by dt, and left side is d kinetic energy by dt. We all know that ma is net force. It is not some individual only force, it is resultant of all the forces acting on a body. So ma is the net force, so we can replace that expression with f net ds, and here is dk. So change in kinetic energy is f net ds. Here is dt, here is dt. If I will cross multiply dt, dt integrate, dt will go. And here now I am integrating. Why I am integrating? Because this force into displacement, we all know force into displacement is work. But as displacement is ds, ds means very, very small, very, very differentially small. dk is very small change in kinetic energy. So that was a small work equal to small change in kinetic energy. If you will take some like initial displacement, initial position to final position, and initial kinetic energy to final kinetic energy, then this expression will be the work done, and that work done due to net force. That's why I told you due to all the forces, due to net force, 2 forces are acting. So include work of first force plus work of second force, overall that work, that numerical value will be the equal to the change in kinetic energy. That is equal to, upper limit here is kf, lower limit is ki, so we can write kf minus ki. Exactly, we got that work done due to net force or work done due to all the forces is equal to change in kinetic energy. That's the work energy theorem. Okay. Now the point comes how to go in the question. So before going that, we will summarize what we did. We started with that work when we do, it either adds kinetic energy, that is the positive work, or it subtracts, like withdraws kinetic energy, that is the negative work. But if work is there, then kinetic energy will change. That amount of change and the work done relation, that is called work energy theorem. Work energy theorem tells you the same information that is being said by Newton's second law, but there you are discussing that law in the terms of force and acceleration and change in momentum. Here we are dealing the same thing but in terms of work and kinetic energy. Then this is the derivation, and here one thing again and again I am repeating, we will keep in mind that work done is not equal to change in kinetic energy. Work done by all the forces, net force is change in kinetic energy. Okay. Now after that, here it comes how to go in question, like is numerical is telling me ki use work energy theorem here. Okay, like it is always a situation based. You are reading a question, there will be some situation given, a ball is falling, right, aeroplane is moving, or something is looping in a circle. Somewhere what situation will be given, always. It is not directly ki what is work, you are putting f dot s, you are getting answer. So work energy theorem is always situation based question, and that situation will not tell you ki use work energy theorem. You have to decide ki this question I need to do with work energy theorem. For that, if you want a help here, so listen very carefully. I am telling you how to pick a numericals. That is a note. Just picking for numericals. If in a question, or if in the question, and these all are for particle dynamics as of now. In particle dynamics in the question, you find that speed changes. Speed changes. A question says that speed is depending on time, speed is depending on position, or directly question says that speed is changing from 2 meter per second to 5 meter per second. Anyhow, in any language format, they are giving you information that speed changes. That is one trigger point. Okay, there you can use work energy theorem. Or you can say, or height changes. What is changing here? Height. So body is falling, or body is rising or rebounding, anyhow height is changing. Projectile motion is there, rebounding motion is there, simple straight line motion is there, motion, the gravity is there, anyhow height is changing. Or last one, both speed and height change. Okay. So these three are the trigger point where to use work energy theorem. So when you do a numerical, situation based numerical, where some situation is given and I found that, or direct equation wise anyway, speed is changing, even in like in semiconductor question, your electron is going from n side to p side, there is a potential barrier in between. So what is the final speed of electron, how much speed changes? Speed changes question can be done by work energy theorem, but I am saying speed changes. Velocity changes might have, like due to direction also, due to magnitude also, always zero in on speed change, magnitude of velocity is changing. Or height changes, or both speed and height change, then your working rule is very, very simple. You first be very, very careful about how many forces are there on the body. As many forces, work done by force 1, work done by force 2, like that, keep writing as many forces, work done by Fn, and these all work that you have to equate to final kinetic energy minus initial kinetic energy. If you are writing this is an equation you have formed. This equation will solve your question. Okay, so that's the very simple thing. And the added advantage is you are not into vectors now. So the vector addition, the resolution, or 2-3 forces are there in the net parallelogram law. These kind of calculation, little complex calculation will not be here, right? So that is arithmetically very easy kind of question. Again, pick this. We will see some question on this. What is the question solving strategy? How would I know? If in a question speed changes or height changes or both speed height change, then I will use work energy theorem. Just for convenience, one simple example, then we will see some problems also. Like suppose I am saying ki this is a track, right? This track, here is one height h1 and this height is h2. Here is a ball and that ball is released with some speed, let's say u. I am asking you what is the ball speed here? V. V is the question. Okay, V is the question. On that basis of V, I can ask you where it will hit the ground or what is the time of flight. Many other questions could be asked, but as of now we will keep it simple. Here at t equal to 0, initially the block had a speed u and it is at height h1. There is no friction given here. There is no friction given. We will consider that surface as smooth. And from ground height is being measured, h1 and h2. What is speed here? So as I am solving this question, I saw that okay, height is changing in this question as well as speed is also changing. The final speed they are asking. So height changes is a confirmed option here. So I will go for work energy theorem. How to go? Then when I am actually solving it, I should be very clear about all the forces acting on the body. So I am measuring this force as gravity and that force is normal reaction as no friction is given. So acting forces are gravity, normal, tension, spring, pseudo. These forces, out of these forces only 2 forces are acting, mg and n. N will be always perpendicular to the velocity or perpendicular to the displacement. Normal reaction will always be perpendicular to the path, and when a force is perpendicular to the displacement, what is the work? 0. So I will write here work done by gravity, first force number 1, work done by normal reaction, and then final kinetic energy, that is half m v square, that is final, u square is initial. Work done by all the forces is change in kinetic energy. Why I did that? Because question has height change. That's the picking point of the question. Work done by mg. Mg is a vertical force. It is acting down, right? And dot product means force and displacement, they must be in the same line. I'm not saying same direction, they must be in the same line. So mg is vertical, so displacement I have to take vertical only. So vertical displacement, first point is at height h1, second point is at height h2. So that displacement, this y displacement is h1 minus h2. So due to gravity, how much work will be there? Force is mg and displacement will be h1 minus h2. As I said, work done by normal will be 0 because normal is perpendicular to velocity here or perpendicular to displacement, and this will be m by 2 v square minus u square, and mm cancelled, and that is the same formula of your kinematics, v square equal to u square plus twice g into delta h h1 minus h2. You might think I can solve this with kinematics, but that was not the point. Point is simply this: if I will square root this, I will get the answer. So when a question has a situation of speed change, height change, or both change, you should be confident enough to use work-energy theorem. And how to use? Go with all the force work and equate it to the change in kinetic energy. That will solve the question. So I hope you got this. The basics of work-energy theorem you have got. Now, if this is clear, we will see this in some of the question. How to go into question, how to practice that. So have a look. Here, question number 1. In this question, simple theory question is this: work-energy theorem is valid in only inertial frame of reference, only non-inertial frame of reference, both inertial and non-inertial frame of reference, does not depend on any frame. Just I told you, work done by all the forces. All the forces is pseudo is also included, conservative, non-conservative, pseudo forces. So any force can, there is no restriction of forces, internal, external. So your observer is standing. Suppose I am saying this. One example, have a look. This is a sphere, okay? I am describing this question by assuming you know the inertial and non-inertial frame. Just for your reference, if I will take here, just for your reference, what is this inertial, non-inertial? So I will say that inertial, when we talk, it means we are talking about a frame whose acceleration is 0. And when we talk about non-inertial, non-inertial means observer or surface or frame whose acceleration is there, either positive or negative, but it is not equal to 0. So acceleration is present. Now on this basis, I will see this question. This is a sphere. On this sphere there is a particle, there is m, and this sphere is accelerating, right? It is accelerating. Obviously it will experience a pseudo force, ma. Apart from pseudo force, there is a gravity and there is a normal. This normal gravity acting in the vertical plane like this, but pseudo will drift it backward, and from this position due to pseudo, it will start drifting and it will come, let's say at theta angle, it will come like this, and from here I am asking you, okay, what is v here? Initially it was at rest. Now this question and this question, that is theory, I am taking a numerical based on this theory, and finally we will get what answer is this. Is speed changing? Yes. Initially it was at rest, no speed. Finally I am asking you the speed. Height changing? Yes. Speed changing, height changing, use work-energy theorem. So when I will use work-energy theorem, no, I will write work done by gravity, work done by normal, plus work done by pseudo. If I am using pseudo force is only used with respect to non-inertial frame. So it means both inertial and non-inertial frame of reference, third should be answer. Understood? So how beautiful is the concept? You don't even have to bother about the reference frame. Where to use everywhere. Inertial, non-inertial, just put all the forces on the body. Work done by all the forces is change in kinetic energy. So what is work done by gravity in this question? Work done by gravity. Gravity is a vertical force. So you will go in vertical displacement. And vertical displacement, if the radius is r, if radius is r, initial radius was r, and that particle came up to here. So this radius is also r. So this vertical displacement, that angle is theta. This from this triangle, that base will be r cos theta. Total radius was r. So this will be r minus r cos theta. That is the vertical displacement. So gravity work, gravity is down, motion is also down. So it is a positive work, force, displacement, same direction. So I will write it as mg into r 1 minus cos theta. Normal work here will be 0. So normal work will not always be 0. Like we are taking some questions where it is coming 0, so don't make a concept that normal work is always 0. When there is a lift question and lift is going up or lift is going down, so normal work will not be 0. In these questions it is becoming 0 because normal is perpendicular to the surface, or perpendicular to the displacement, or perpendicular to the velocity at every instant. That's why it is 0. MA is acting back. MA is acting leftward. So displacement M is here. So displacement also I will take here, and this will be r sine theta. So what I will write? MA into r sine theta. You can see these two are positive work. This is also positive, this is also positive. And positive work will add the kinetic energy, no? So kinetic energy is being added. Earlier there was no kinetic energy as it was at rest. Speed 0, kinetic energy 0. At this point some kinetic energy is being added to it, and then we will write final kinetic energy half mv square minus 0. I can cancel m, and from here our v will be 2, right? 2 will be cross multiplied. R is common here, and this is g into 1 minus cos theta plus here sin theta under root, that will be value of v. If theta will be given some 30 degrees, 60 degrees, g we know, r is given, we can have a numerical value. But that's not the question here. Question here is, I'm so sure that whenever speed height will change, I will use work energy theorem in any situation. Number 1. Number 2, I don't have to bother about the forces, which force is there. Like when you are going in conservation of mechanical energy, you can solve this question by that also. Only pseudo is not there. Conservation of mechanical energy deals with conservative forces only, right? Non-conservative force is there, so you cannot use conservation of mechanical energy. So conservation of mechanical energy comes with if and but. Here don't use, here use, here don't use. But work energy theorem is giving you such an accurate question in situation based question, accurate tool. You don't have to bother about the forces, you don't have to bother about the frame of reference. Just use wherever height change, speed change, all the force, work, change in kinetic energy. So you can rely on this theorem, work energy theorem. I hope you got the answer of this question. It can be used everywhere, all types of forces. Okay. Next question we will see. Question number 2. Have a look on this question. Have a read. In this question, there is a mass of 1 kg, and for the mass of 1 kg, see, here is the mass of 1 kg, right? And then displacement is given because motion is on y-axis. This is position given, and change in position is the displacement, and rate of change of that displacement is velocity. The work done by all the forces, see this important word, all the forces. Work done by all the forces on the particle during t equal to 0 to t equal to 4. That's the point we have, right? So we understood this question. What this question is asking? Work done by all the forces, but that is equal to change in kinetic energy. Where is the speed? Speed is there, no, but not directly given. This is y, which is equal to t square minus 4t plus 5. So what will be speed? On y-axis motion is there. Speed on y-axis, magnitude of velocity dy by dt, 2t minus 4. Okay, now we have v. Is that v changing? Try to think. Of course it is changing because it is depending on t, and time changes. Accordingly, v will also change. So our initial time here is 0. So at t equal to 0, what speed you have? 2 into 0 minus 4. Minus 4 meter per second. That minus 4, but obviously it will be 4 because I am talking about speed. So I will take magnitude. So magnitude will be 4 meter per second. Minus is only indicating direction of velocity, but I am not bothered about this. I will focus on speed. Speed is always positive. Then at t equal to, next time my question is asking at 4 second. At 4 second, here I have to put t equal to 4. So what will be this? Final velocity is 2 into 4 minus 4. That is 8 minus 4, and 8 minus 4 is also. In this question, is that speed changing? 4 to 4, is that speed changing? No. Initial, final, 4, 4. speed does not change, so kinetic energy will also not change. It means here initial kinetic energy equal to final kinetic energy, and both are equal to half. M is 1, V is 4 square. So when both kinetic energy is same, they are same, sorry, then kinetic energy change is 0. And work done by all the forces equal to change in kinetic energy. So which option we will take, my dear? The option will be 0, because kinetic energy is not changing. So even if individual forces are doing work, their work is being cancelled. Some work will be positive, some work will be negative, and overall work is 0. Okay, because kinetic energy is not changing. So these kind of question, many students solve these question by finding acceleration. Like first you will differentiate y, you will get velocity. Then you will differentiate velocity, you will get acceleration. That acceleration multiplied by m, you will get force. Then force into displacement, that is work. I strongly suggest you don't go there. Whenever displacement or position depends on time, you don't go on acceleration, just go on velocity and initial minus final, change in kinetic energy, their work you will get. You don't need to go on A and add one more or two more steps and take longer duration of time to solve the question. So whenever your position or velocity changes, solve by work energy theorem. Don't try to go on force into displacement or all. That's not the suggested methods to solve these kind of questions. I hope you got that. So 2 questions we have done. Now come to question number 3. Have a look here. In this question also, V is, what is V? Body mass is given. Travels in straight line, that is a one-dimensional motion. V is this, and again V depends on x, because A is the constant. V depends on x and V depends on x. Some body is moving, so x means position. Position will keep changing, and position is changing, then position dependent speed will also change, no? So that body is moving in straight line with V equal to this, that V is not constant, that V is changing. The work done by the net force, see the terminology of question, work done by net force, work done by all the forces, it triggers you, tells you use work energy theorem. And moreover, speed is also changing because the speed is depending on x during its displacement from x equal to 0 to x equal to 2. Just we have discussed that whenever speed changes equation wise, I will not go on acceleration. I will change kinetic energy and we will find the work. So acceleration is not required here. V is how much? A, x raised to power 3 by 2, and according to question our initial x is 0. So initial velocity Vi, that will be 0. If I am putting x equal to 0, we will get 0. Then the final one is 2. What is V final? V final is A is a constant, x value is 2 and 2 raised to power 3 by 2, right? A value, numerical value is 5, 5 into 2 raised to power 3 by 2, that is the value of final velocity. As question is asking us net work, we know that first of all speed changing or not, of course it is changing as x is changing, and whenever speed changes or height changes, we can go in work energy theorem. So net work will be equal to final kinetic energy minus initial. Final is half m, m is given as 0.5, we can write 1 by 2, and v square is 5 square, that is 25, and if I will square it, it will be 2 raised to power 3. Denominator is 2 raised to power 2, that is 2 raised to power 3, so that will be cancelled and answer will be 50 joule. As simple as that. Okay, so equation questions, expression questions, V is given, Y is given. Don't try to go on acceleration. Most of the time, rather all the time, you can solve question by change in kinetic energy if question is asking you for work. Okay, so that same thing repeatedly we are discussing. So again I am up to this question I am summarizing what we have done. Work energy theorem is our scalar treatment of Newton's second law. In what kind of question? Use situation based question where speed and height are changing or both are changing. How to do? Write work by all the forces and equate change in kinetic energy, final minus initial. And in expression equation kind of question, v is given, y is given variable. So don't get on acceleration, just change the speed. Up to speed you have to come. Y given, x given, come to v. V directly given, then final v and initial v. And then using that v, change in kinetic energy, and that will give you net work. I hope you got that. Come to this question. First we will do this. Have a look on this question. Try to understand. What is this question? At each point, like F is your force. You can see force is acting on it. And force is always along the tangent. Means here force is like this. Here if the block will reach along tangent. Tangent means along the surface. That force is along the surface. The force is along the surface. Understood? Tangent means along the surface. Always. If block reached here, it is along the surface like this. So work performed by this force is what? Okay. I will assume that here it is starting the motion with zero initial velocity, because force is acting, and if force is not acting, it might go down because it is smooth. It might go down because of component of gravity there. So initial speed was zero. There was a force required to slowly haul it up, and here it has reached. So I am taking final velocity also as zero. So just here to here motion is there, initial to final. That is part of question you can write. Initial is zero, final is zero. Now how to go in the solving? I simple have a situation and I know the concept. If height changes or speed changes, you think either of these two changes. Height is very clear cut changing. Then in these kind of question I will use work-energy theorem. How to use? Identify the force. What force we can identify here? You should not skip any of the forces. mg, normal, and the applied force is F. There is no friction. So work done by gravity plus work done by normal plus work done by F, that will be final kinetic energy minus initial. But final kinetic energy has to be zero because speed is zero. Initial is also zero because initial speed was also zero. Work done by gravity. Where is the gravity acting? Downward. And where is the motion? Upward. They are opposite. Opposite means negative work. Fs cos 180 degree. So mg is vertical. So I will go for vertical displacement, that is h. But since h is up, mg is down, that work will be minus mgh. Right? Work done by normal zero. Same logic. It is perpendicular to displacement. Every instant normal will be in such a way that it is perpendicular to displacement. And work done by F is required, that we don't know. Final zero, initial zero. In this question, don't go with that if you are finding displacement. You force their work, they are asking F into displacement. Don't try to find the displacement. That is not possible also. Like here displacement, it is always tangent. In this option is not there, but many kids can do that mistake. They might think, okay, this is L, this is H, that is the displacement, and I can use L square plus H square. My dear students, you cannot use this. This can only be used when your force is always acting in this direction. If force is always acting in this direction, then that is the displacement, that is the force. Multiply these two, you got the work. But that's not the question. Question, force is always along the tangent, and that force is sometimes acting here, force sometimes acting here. So force direction is changing. It is not always acting along that direction. So that displacement into force will not work here. So that's why force into displacement is not going to work in that question. What you will do? You will use work-energy theorem, and here WF will be equal to mgh. This minus mgh will go that side and it will be mgh. So mgh we will take third option you can write. Okay. So some of the time when solving question by the force displacement are very, very critical. Just one line you can use and you can solve this question. Got it? Clear? I hope you got it. Say this question again. Again have a look. What this question is saying is that speed change or height change works here. Ratio of work required to accelerate a car from V to 2V. V to 2V. Work 1. When I am doing work 1 here, please have a look. Work 1, half m final minus initial. Why I am so sure? speed changes V to 2V, that is work energy theorem. And for that, what work is there? And this work is net work. As many forces are acting, all combined work is half mv final square minus half mv initial square. Final is 2v, 4v square. Initial is v square, that is w1. Then question is asking work required to accelerate it from 0 to v. Work required to accelerate it from 0 to v. What is your w2? Half m. Final speed in this case is v and initial speed is 0. When you will take ratio of these two, half m cancelled, that is coming 4v square, that is 3v square, and here it is v square is cancelled, and the answer is 3:1. That is your option number 3rd. Simple, as simple. So whenever speed changing, directly, indirectly, height changing, don't hesitate in using work energy theorem. As I told you, there is no constraint of force, there is no condition of frame. That is most of the time you can directly use. Like Newtonian mechanics, always you can use. Sometimes in quantum physics here and there, but that's not on your NEET level or JEE level. There you can use in almost all the questions. All the questions, almost is not also the proper word. Always use. Whenever height changes, speed changes, use work energy theorem. Okay. So that was the questions, that was the concept. Now attempt some questions, see PYQs, see how much it is helping you. I am sure if you will get it done, the basic summary, whenever speed height changes, I will use work energy theorem. And how I will use, I will write all the forces first. Don't skip any. Friction, spring, normal, pseudo, whatever is acting. And work done due to all the forces combined equal to change in kinetic energy. In equation questions, V given, Y given, then always try to come to V. V given already, final minus initial, square square. Y given, differentiate, come to V. Don't go on acceleration, don't calculate force, that's not required. That's the basic summary of work energy theorem. Then we will meet again for some more concepts, some more basics, solve questions. All the best, God bless.